Hello, this is Kwang Hak. For this fluid simulation assignment, our team enhanced the particle system to simulate splashing when the pen tilts suddenly or when particles collide with the wall, and implemented realistic motion and higher velocity for splashing particles. Let me show you the result we got from the code. So this is the cake pen with water simulation. So if I tilt it up, the particle if the particle hits the uh uh the top part, it's gonna bounce it, and if I tilt it to the bottom, it also like the particles bounce. And we can also uh if I tilt it to the right, yeah, as you can see, also tilt it to the right and tilt it to the left. Again, tilt it to the left and the down and tilt it to the up. Particles bounce when they hit the walls. Now let me go over the code. This is all the code from the textbook. And we have added some variables. So is flash is we have a boolean is fresh is set it to false. Is that the particle if is a like a splash particle, and flow lifetime is set it to 0.3f. This is the duration that a splash particle like is floating until they hit the ground. And time alive, this tracks how long a splash particle has been alive. And this initialize a particle with position x, y, z, and for the velocity of vx, vy, and vz. And a boolean is fresh if splash to differentiate between normal and splash particle. For this part, ensures that splash particles disappear after a short period. If the particle, uh, if is flash, increment the time alive, and if time alive exceeds the lifetime, the splash particle is removed, so it's out of bounds and set it to true. And this ensures that normal water particle remain inside the pen and ensure realistic motion. So uh, pen y, float pen y is equal to cake pen position y. This gets the correct y position based on the tilt. And if the particle is not a flash and is it in the like uh pen surface, and it's uh so y equals pen y, this snaps to the surface, and uh vy, oh, it's here. Vy equals negative vy times 0.3f. This bounce up slightly, and this applies our friction to horizontal motion. And this prevents too many splash particles from being generated, keeping the effect realistic. So use the 20% to determine, random probability of like 20% to determine if a splash effect should occur, and cause the spawn splash particles to create a splash particle. And this ensures that splashes occur when particles hit the front or back of the pan, as I showed before. So check for collisions along the axis instead of x-axis because it's like front or back. And for the code I wrote, it creates dynamic and natural looking splashes when water hits the pen walls. Generates the splash particles with randomized velocity, uh, Vx, Vy, and Vz to simulate like natural spray motion, and slightly going upward push for this random next float times 0.3 app. And this stores previous tilt value of the pen. And this simulates water splashing when the pen moves suddenly, so creates the change in tilt. So in delta tilt x and delta tilt z, and if the change is larger than the tilt threshold, it triggers spawn splash form tilt. And for this part, adds extra like realism by making water splash up when the pen is tilted like unexpectedly. So so it selects the random particle I plus equals to 20. This reduces the frequency, and this creates the splash particles with upward motion. And for this part, it helps visually distinguish between regular water and splashing water. So for the splash particle, it has lighter blue color. This is the value of lighter blue color, and the normal water particles representing the with the no darker blue, which is this one. I think this is it for fluid simulation assignment. Thank you for listening.